Okay, we're going to look at an example problem, which is analyzing the graph of a quadratic function, and we're going to try to compute a couple of things by looking at the calculator or using the calculator. So first of all, we're going to graph this function. The function is 2x squared plus 6x minus 17, and we're going to use the graphing calculator to estimate the vertex, rounding our answer to the nearest hundredth, and also estimate the x-intercepts and round those to the nearest hundredth as well. So first thing I do over here is I'm going to go to my calculator, and if you just turn on the TI, excuse me, 83 or 84, you'll see the blinking cursor. And if you haven't yet, you can graph by pressing this y equals button at the top. And basically what happens here, any one of these rows is going to be an equation. And on the calculator, we can graph basically any equation of x and y as long as it's solved for y. So for example, over here, this is an equation solved for y. F of x is just another name for y. So first thing I'm going to do is type in the function. So this function is 2x squared, okay, plus 6x minus 17. Okay, so then after I've edited the equation under this y equals button, this is the equation editor, by the way, then I go over here and I hit graph, and that should show me the graph. Now, in this case, this is one of those situations where when we look at a graph, we might want to change the window. One of my problems asks me, in fact, the first one asks me to find the vertex. You can see the parabola shape, but the vertex is somewhere down below. So in this window, the smallest y value I can see is negative 10. On our calculator, we can change that. So I press the window button, and I arrow down here, and I change the y min from negative 10 to something smaller. So we sometimes have to do this by a little trial and error, but I'm going to make it negative 20. And when I do that, I'll look back at the graph. So I push the graph button. And now you can see it's actually showing me 20 tick marks down. So that's 20 units down. I can't quite see the vertex, so I'm going to go back one more time and make the y min negative 30. And that seems like that'll probably be enough. Okay. Yeah, excuse me. Okay, great. So we see the parabola, including that vertex that we want to find. Now, real quick on the window, I think it's probably worth our time to change one more thing. When you're showing a lot of distance on the y-axis or the x-axis, you don't really want one tick mark per unit because you end up getting kind of this blurry, mess of tick marks. It doesn't really help. So if I go back to the window, I'm going to change on the y-axis, I'm going to make the scale 5. Okay. So you can make that change. You can also change the scale on the x-axis if you need to, and x-min and x-max. But I don't think we really need to do that at this point. So now when I go back, the graph's going to look a little bit clearer. On the y-axis, we're counting by 5. So right here, we've got negative 5, negative 10, negative 15, and so forth. Okay, so first things first, we want this vertex, and we want to get it accurately. So there's a feature on the calculator that will do that for us. So to find the vertex, you go down here and you press second and trace, which brings up this calc menu. And if you notice, you don't see vertex here, but we can have our calculator find maximums and minimums. Well, in this problem, our vertex is also what we call a minimum value for the function. So second calc brings me to this menu, second trace, I'm sorry, and then I pick 3 to find a minimum. Okay, so basically the calculator is going to find that point for us, but we have to help it out a little bit and tell it where to look. If you notice, it's asking me for a left bound. I have to tell it basically how far left to look to find that minimum. So roughly the x-coordinate is maybe negative 2. I'm just taking a wild guess here for that minimum. So I'm going to tell the calculator, look as far left as negative 3. So I actually can just go down here and type negative 3 for my left bound and press enter. Okay. And when I do that, you might see there's a little arrow that pops up here. It's telling the calculator to look for the minimum to the right, okay, because that's my left bound. Now it's asking me for a right bound. So I'm going to give it a number that is safely to the right of that minimum. And again, I'm just typing in the x-coordinate. So for example, right here, the x-coordinate is 0. Okay, right? When you're at the origin, the x-coordinate is 0. And that's safely to the right of the minimum. So for the right bound, I'm going to press 0, enter. And finally, now it knows to look for the minimum between these 2 points. Press enter one more time. You don't have to give it a guess. You can give it a guess if you want, but if we just press enter, it'll be fine. Takes a second or two, and here's what it tells us. There is the minimum. Okay, so to 2 decimal places, to the nearest hundredth, that would be negative 1.50, comma, negative 21.50. Okay, at the bottom of the screen, it tells me the answer. So just to be clear, I'm going to round it to the hundredths decimal place, which is 2 digits to the right of the decimal place. Okay, and that's what they wanted. So that would be my ordered pair for the minimum, which is the vertex. Okay. Okay, so there's another feature on the calculator we can use to find x-intercepts. Again, sometimes we solve for those, but if you want, you can have the calculator find them for you. So we'll go ahead and do that. Go back to this calc menu. So from the graph, we hit second, trace, and we look for these zeros. A zero is just another name for an x-intercept, basically. So I press 2 here. And again, it's going to ask me where to look, and I have to know roughly where the 0 is. Okay, so this 0 is approximately, this x-intercept is approximately negative 5. Now, it might be exactly negative 5, or it could be negative 4.95 or something close. So that's why we're using this, just to find it for sure. Now, the calculator's asking me for a left bound and a right bound. So I have to give it numbers which are safely to the left and to the right. So for the left bound here, I'm going to give it negative 6. And for the right bound, negative 4. Okay, and again, those come from the fact that I'm pretty sure that x-intercept is really close to negative 5. Okay, so again, I can give the calculator a guess, but I've never had a problem where you really need to. So we'll just press enter for the guess. And after a second or so, there you go. It gives us the x-intercept, at least approximately. So if we round this to 2 decimal places, it would be negative 4.78. Okay, that's the x-coordinate. And of course, for an x-intercept, the y-coordinate is 0. Okay, so if we have 2 x-intercepts, that's no problem. We can find the second one as well. We'll go right back, hit second, trace, select 0 again. Okay, and then now to find this one over here, we're going to basically do the same thing we just did, but I'm going to give it a left bound and a right bound that are appropriate for that 0. So if I had to take a guess here, I'd say it's around positive 2. So for a left bound, I'll give it 1. Okay, and a right bound, let's give it 3. Okay, and again, it puts these little arrows on the calculator to tell you it's going to look in here, okay, to find the 0. If you want, you can type in a guess at this point, but it doesn't really seem to make any difference in the calculator's ability to find the 0. So I'll just press enter. And after a second, it gives us the other x-intercept, which would be approximately 1.78, 0. Okay, notice the x and y coordinate are always here after it finds these things. Okay, so that's basically it. We've located the points, we've rounded them to the required precision that was given in the problem, and that's pretty much it. So if you were graphing or you're done graphing, now you can hit second and mode to quit, and it takes you back to the main screen. Okay, so in summary, y equals, that's how we graph equations. Window we can change to anything we need to. We've got the mins and maxes and the scales on each axis. And then graph is where we look at our equation. All right, thanks.